What if I told you that one single activity, something millions of people do purely for enjoyment, produces more simultaneous brain activation than almost anything else a human being can do? Not studying, not solving math problems, not even learning a new language, playing a musical instrument, and the neuroscience behind this is not just fascinating, it has real measurable consequences for your memory, your focus, your emotional regulation, and even how well your brain ages. Welcome to Psychology with Sergiu Popovici. I'm a psychologist based in Munich, Germany, and on this channel we translate cutting-edge research in psychology and neuroscience into something you can actually use. If this is your first time here, I'd love for you to subscribe because what we're covering today is one of the most well-supported topics in all of cognitive neuroscience. Let's start with a question. What does your brain actually do when you play an instrument? The answer is almost overwhelmingly complex. At any given moment while playing music, your brain is simultaneously decoding written notation, translating it into motor commands, sending those commands to your fingers with extraordinary precision, listening to the sound you're producing, comparing it in real time to what you intended, adjusting for any deviation, tracking rhythm and timing, regulating breath or posture, and often reading ahead to anticipate what comes next. All of this happens in fractions of a second continuously. Neuroscientists have described the experience of playing a musical instrument as one of the most complete neurological workouts a human brain can perform, and like any workout, when done consistently, it changes the brain's structure. Let's talk about what those structural changes actually look like. One of the most consistent findings in music neuroscience involves a part of the brain called the corpus callosum. This is the dense bundle of nerve fibers connecting the left and right hemispheres of the brain. Think of it as the main highway between two cities. The bigger and more developed the highway, the faster and more efficiently the two sides can communicate. Research has consistently shown that musicians have a significantly larger corpus callosum than non-musicians. This difference is especially pronounced in musicians who began training before the age of 7, but it is observable across all age groups. What does a larger corpus callosum mean in practice? Faster processing, better coordination between logical thinking and creative thinking, more efficient communication between the analytical and the emotional brain. Then there's the concept of neuroplasticity, the brain's ability to reorganize itself, to build new neural connections, and to adapt in response to experience. For a long time, scientists believed that after a certain age, the brain's structure was essentially fixed. We now know that is not true. The brain retains the capacity for change throughout life, but not all activities drive this change equally. Musical training is one of the most powerful neuroplasticity triggers we have identified. A landmark study from the University of Zurich, involving 153 participants, musicians with absolute pitch, musicians without, and non-musicians, found that long-term musical training is associated with robust changes in large-scale brain networks. Musicians showed significantly stronger structural and functional connectivity, both within and between hemispheres, particularly in regions responsible for processing sound, speech, and movement. In plain language, the musician's brain is more connected, more integrated, more efficient. Now let's look at specific cognitive benefits because this is where it gets directly relevant to your everyday life. The first area is memory. Research published in PMC found that musical training strengthens the hippocampus, the brain structure central to memory formation and spatial navigation. Musicians show enhanced responses to novelty in the hippocampus, and studies have demonstrated a direct correlation between musical training and superior verbal memory. Children who received music training showed better verbal memory, stronger reading abilities, and higher scores on language-related tasks compared to those without musical training. These advantages persisted well into adulthood. This is not coincidence. Music and language share overlapping neural circuits. Training one reinforces the other. The second area is executive function. Executive function is the set of cognitive processes that allow you to plan, focus, switch between tasks, and regulate your behavior. It's essentially your brain's management system, and it's one of the first things to decline with age. Playing an instrument demands constant use of executive function. Your brain must track rhythm, timing, pitch, and movement simultaneously. It must suppress mistakes and self-correct in real time. It must hold musical information in working memory while executing motor sequences. A 2024 systematic review and meta-analysis published in Science Direct examined the effects of musical instrument training specifically on executive function in healthy older adults. The conclusion was clear: musical training produces measurable improvements in working memory, cognitive switching, and processing speed. These are not small effects. These are meaningful, clinically relevant improvements. The third area is emotional regulation and stress. Music engages the brain's reward system directly. Playing an instrument triggers dopamine release, the same neurotransmitter involved in motivation, pleasure, and reward. It activates the nucleus accumbens and the ventromedial prefrontal cortex, regions deeply involved in how we experience positive emotion. Consistent musical practice has been associated with lower levels of anxiety, better emotional regulation, and reduced physiological stress markers. The focus required during practice also functions as a natural form of mindfulness, pulling attention completely into the present moment and away from rumination. Now, here is one of the most important findings for anyone who thinks they are simply too old to start. Research has shown that playing an instrument protects against age-related brain atrophy, the gradual shrinking of brain tissue that occurs as we age. One study found that musical training helps preserve both gray matter and white matter volume in older adults. Another found that even beginning instruction in middle adulthood generates structural brain changes. The implication is profound. Learning an instrument is not just an investment in skill, it is an investment in cognitive longevity, and you do not need to become a professional musician for this to matter. Research consistently shows that even 10 to 20 minutes of daily focused practice produces neurological benefits. It is the consistency and engagement that drives the change, not performance level. A beginner practicing daily is already rewiring their brain. Let me bring all of this together. When you learn to play a musical instrument, you are simultaneously training your motor system, your auditory system, your memory, your attention, your emotional regulation, and the coordination between your brain's two hemispheres. There is almost no other single activity that touches this many systems at once, and the effects are not temporary. Neuroimaging studies show that musical training leaves structural traces in the brain, changes that persist even after active practice stops. Your musical history becomes literally embedded in the architecture of your brain. So what does this mean for you practically? If you've always wanted to learn an instrument, this is your sign, not because you need to perform for anyone, not because you need to achieve any particular standard, but because the act of learning and practicing consistently over time is one of the most complete forms of brain training available to us. If you played an instrument as a child and stopped, consider picking it up again. The neural foundations from early training don't disappear. They can be reactivated faster than you might expect. If you're already playing, understand that what you're doing is far more than a hobby. Every practice session is an active investment in your cognitive health. And if you feel like you're too old or not talented enough, the research disagrees with you. Neuroplasticity does not require talent, it requires consistency. If you're watching from somewhere in Europe and you're struggling with stress, anxiety, burnout, or simply feel like your mind isn't working the way it used to, I work with clients as a psychologist based in Munich, Germany. You're very welcome to reach out through the links in the description below. If this video added something to your understanding, please consider liking it and sharing it with someone you think would benefit, and subscribe to Psychology with Sergiu Popovici for more research-based psychology every week. See you in the next one.